Alright, so now we're gonna look at how to find the Thevenin and Norton equivalent of this circuit. So you guys all see that you have a dependent source right over here. Is this not an independent source? So we can't find RTH, the Thevenin resistors, by using special case, which is we have to find the open circuit's voltage and the source circuit's current. Okay, so let's do it. I'm going to redraw this circuit to find the source circuit's current first. So I'm gonna take out this one and kind of plug it in. Source circuit's current. Okay, this is point A, this is point B. All right. So what you guys see over here, this part should be 0 amp because this is parallel with the resistors right over here. And this part is also 0 ampere because short circuit's currents go like this. Okay, we got the idea. So now we have that Ix is equal to 0 amp. So therefore, we're gonna redraw this circuit. This is 25 volt. And we got 5 ohms here. And in series with a 10 ohms. And this is your short circuit current attached to it. All right. Good. So the source circuit current is going to equal to Ohm's law, voltage divided by resistors. And the resistors right here is 10 plus 5, which is 15. And that's gonna give me 5/3 amp. Good. Now we're gonna need to find the open circuit's voltage. Again, I'm gonna redraw this circuit to find the open circuit voltage. Gonna name this one ISE. All right. So our open circuit's voltage is right here. Right, I'm gonna set this point as point P. This is I1 flowing through the loop. All right. So what I'm going to do is I'm going to KCL around P. Right. So what do we have? We got 0.5 Ix is flowing out, I1 is coming in, and Ix is coming out. So we have I1 negative 0.5 Ix and negative negative Ix. So we got, okay. What I would like to do next is KVL around the loop. What for? I would like to find Ix. So I'm gonna KVL around the loop. Okay. So that should give me 25 volt voltage. So I take I1 flowing when this way. Oh, I'm sorry. That which means I'm going to set all right. So we got the idea. Okay. So we have 25 volt subtract to 5I1, we have here is 10 ohm resistors and 0.5 Ix. And this one is Ix. We're not going to take a look at 0.5 Ix because the loop that I'm taking a look at is this loop. All right. Whoops. Okay. So this should give me 5I1 plus 20Ix is equal to 25. Why I did that? I multiply by -1 for this one to get 5I1 instead of -5I1. Okay. We got the idea. Right. I'm gonna name this function number 1. This one is number 2. And what I would like to do is I'm going to take number 2 to subtract number 1 to find the Ix. So that should give me 4Ix plus 1.5Ix is equal to 5. And we have 5.5Ix is equal to 5. So Ix should be 5 over 5.5 amp. Okay. I'm gonna keep it like this instead of writing 0.90909. I'm gonna keep it like this. Okay. So now we can find VOC. The open circuit voltage of us right now going to be Ix multiplied by 10. Here. And that should give us 5 over 5.5. Oh, sorry. Multiplied by 10. And that should give me around 9.090 volt. And we have the source circuit current, which we just calculated above here, 5 over 3A. And we have the open circuit voltage. So now we can find the Thevenin resistors. So our Thevenin going to equal to the open circuit voltage divided to the source circuit current. And that should give me 5 over 5.5 divided to 5 over 3. Okay. And this one should give me 30 over 5.5 ohms. I'm sorry. And that is 5.45. So now we can draw our circuits within the Norton equivalent and Thevenin equivalent. Okay, so firstly I'm gonna draw the Thevenin equivalent of the circuit. This is VOC, which is 9.09 volt. And this is our Thevenin, which is 5.45. This one going to be the Norton equivalent. So we have the current source circuit current, 5 over 3 amp, and the parallel resistors, which is 5.45. Right, good. So that's how you guys find the Thevenin and Norton equivalent circuits for the circuit which have the dependent source, like this. Thank you. See you guys in the next video.